Right, welcome. This I want to have as the last lesson for the 91161 calculations, and we're going to be looking at the titration ones. So the only formula you have to know is this particular one. So think of the caret. C is equal to N over V. Okay, that's the one you're going to be using with. Now for titration, you always have two solutions. For level 2, it's an acid and a base. Okay. For one of them, and we'll just call it solution A, it could be the acid or the base, you know both the concentration and you know the volume. You know the volume because you've got the pipette and the burette. With solution B, you know the volume because, as I say, you've got the burette or the pipette, but you don't know its concentration, and that's what we're going to be going for. Okay, so let's see an example of this. So here's an example. You are titrating citric acid against sodium hydroxide, and as I say, always look to see in the question what the substances you're dealing with, or the substances, and what relates to that substance. So in green, I'm going to put the citric acid. Okay. Now we need to calculate the concentration of citric acid. So this is our substance B, the one we don't know the concentration. But we do know the volume, and there is the volume. How do I know it's the volume? What do I look at after the number, after 20, to know it's a volume? The milliliters. So that's why I say you have to know the units. So that poem I gave you, and if you need Quizlets, just make sure you know the units. Now we do see that the units here is milliliter. Is that the correct unit for volume? No. So we have to convert milliliters to liters. So milli means 1,000. So do I multiply by 1,000 or do I divide by 1,000? Now one way is trying to imagine the amount. Correct, Carol, we divide. Because if I've got 20 moles, it's like a tablespoon. So if I've got a tablespoon of citric acid, if I multiply by 1,000 to get to liters, it's going to be like 20,000 Coke bottles. So is one tablespoon the same volume as 20,000 Coke bottles? So just use visualization like that to work. No, it can't multiply like that, so I must divide. So it would be like 1/10 of the amount in a Coke bottle, or actually less than that, but anyway. Right, so that's the one substance and what we know about it. It's just the volume. And the other substance is my sodium hydroxide, and I know two things about it. Remember what we said, we'd always know the concentration and we always know the volume. And the same thing we have to convert. So in this, just like what we do before, is the easiest is drawing a line and having everything to do with sodium hydroxide on one side and everything to do with the other substance on the other side. Now, because we know less about citric acid, I've made it on the right-hand side because this is what we're finding. Okay. And if you don't want to do this way, then make sure you always put the substance in brackets so you know what substance you're dealing with. So let's start off with, what do I know with the sodium hydroxide? I know the concentration, and as I say, it helps if you put the units down. So it's 0.125 moles per liter. I'm a little bit slow with this. Now remember, it's moles per liter, and it's not just minus, it's -1. It's one of the few times I put in a 1. Hello, Grace. Nice that you could join in. So I know that, and I know V, and I have to convert that V. So it's 26.5 milliliters. And the way to convert it is either dividing by 1,000, or I could multiply by 10 to the -3. because 10 to the minus 3 is the same as dividing by 1,000. Use whatever method you like. Okay, so I just have to now apply this formula. C is equal to N over V. Think of that caret. So that's, and use units as well to see what to do. So I am looking for N, because remember, if I've got the concentration and I've got the volume, you always aim for amount. You have to have amount because you have to have the amount to swap from one substance to the other. I can't compare masses directly. I can only compare amounts directly. So to work out my number of moles of sodium hydroxide, do I multiply? Is it N is equal to C times V? Or is it C divided by V? Or V divided by C? So Declan is typing there. You multiply. Okay, and so it'll be 0. Now have your calculators ready so that you can work this out. So it'll be multiply 26.5 times 10 to the 3 negative, or 10 to the minus 3. I'm just going to put it on over there. Now, if I haven't written my units in, but I've got moles per litre multiplied by litre, so if I just change these colors, hopefully you'll see that this litre will cancel out the per litre there, leaving me an answer with mole. So I'm just quickly going to get my calculator and work that out, and you see if you get the same result. Did you get 3.312 times 10 to the minus 3? Great. Yep. I didn't bother putting in all the numbers. Keep all those numbers in your calculator, okay? So I'm just using what I call scientific notation. Okay, so this is a mole. What we do now is we apply our mole ratio because we've got the amount. So to get to this side, which is B, in other words, the citric acid, I need to use the mole ratio. Now I see name question mark has raised their hand. Do they have a particular question, or did they just click on that raise hand button? Okay, I see name is typing. Just clicked it. Okay, fine. You can unclick it if you like, or you can leave it there. Right, so we use our mole ratio, which we get from our balanced equation. 1 citric acid requires 3 sodium hydroxides. Okay, so reversing it, because I've got a, if I have a 1 sodium hydroxide, how much citric acid do I need? Does anybody want to have a go? Because this is the first time we're sort of working backwards. Before it was just easy, multiply by 2. But now we actually have got a 3 in front of the known substance, not the unknown. So, okay, not quite. Because it's 1 citric acid needs 3 sodium hydroxides, then if I have 1 citric acid, I'm going to need only if I have 1 sodium hydroxide, I only need 1/3 citric acid. So if I'm trying to put a 1 in front of the sodium hydroxide, can you see I have to divide that 3 by 3 to get a 1 in front of the sodium hydroxide? And if I put divided by 3 there, can you see I need to also divide the citric acid by 3? So this figure that I've I've worked out for my moles of sodium hydroxide, I now, instead of doubling it or tripling it, I have to multiply it by 3 to get citric acid. So I've got 1/3 the amount needed of sodium hydroxide. And what is my sodium hydroxide? It's 3.312, and as I say, keep all those figures in your calculator that you had, times 10 to the minus 3. I hope you can read my writing because it's not very easy. Okay, so I'm going to just get my calculator and divide by 3. That's the easiest way of doing it. And do you get 1.1041666 recurring? So times 10 to the minus 3. 1.01. And I must admit it's gone again. 41. I'll just make it 42. 1.1042. So that's supposed to be a 4 times 10 to the minus 3. So I know now my moles of citric acid. So this, as I say, is the first time where we've come across where we haven't had to double, it's where we've had to divide. And the way you do it is, if this is my substance A with a big number, with a number in front, and I'm trying to change it where I don't know the number, convert this to the 1 by dividing it by itself, and that means whatever that is, you've got to divide the citric acid by that same amount. So I know N, to get to the concentration of B, is the volume. So do I say N is C is equal to N times V or N over V? What is it? As I say, try and remember that caret in your head. Do I multiply or divide? I divide, correct. So as I say, if you remember that caret, then it's my moles over there. So 1.10, yikes, 42 times 10 to the minus 3 all over my volume. Now this is where it can get tricky if you're not sure how to use your calculator, because your volume of citric acid is, remember what I highlighted in green above, it's 20 milliliters, and to convert 20 milliliters I have to divide by 1,000 or multiply by 10 to the minus 3. Now if you have scientific notation, I'll just change it to another color. I think you can see easily that those are just going to cancel out. That's why I like using scientific notation like this. But otherwise, make sure you know how to use your calculator correctly and that you get to the final answer. Because with some calculators, if you take this top number and then say divide it by 20 times 10 to the minus 3, for some calculators they will still divide it, and for others they will multiply it. So just make sure you know how to use your calculator. And so I just go this and I divide it by 20 times 10 to the minus 3. And do you get an answer of 0.0552? Right. And I haven't got excellence yet, even though I have got my 3 significant figures. What do I need to write down? So Nicholas is typing moles per liter, correct. Okay, you have to have your units in your final answer. So You should have at least 3 significant figures all throughout. I know I was a bit naughty over there. I should have used 3 significant figures there. But we're not too sticky on that 0. But you should, in these in-between calculations, have at least 3 significant figures. Don't drop down to 1 or 2 significant figures and then give 3 at the end. Keep, as I say, a minimum of 3. So that is straightforward. You follow the concentration with the volume to get to amount, use the mole ratio to get the amount of the other substance, then use the volume to get the concentration. There's only 2 things you've got to watch out for is make sure your milliliters are changed to liters, okay, and the other one is your mole ratio. Make sure you know when to divide and when to multiply. So to me it's easiest to picture. If it's 1 citric acid is to 3 sodium hydroxide, it'll be 10 citric acid to 30 sodium hydroxide. So you're always going to have more sodium hydroxide. So if this number over here that you calculated is more than your number of moles of sodium hydroxide, can you see you've done the wrong thing? You're going to need less citric acid, okay, than the amount of sodium hydroxide. So will that help you decide whether to multiply or divide? So just think of, I always need more sodium hydroxide, so this number must be bigger than the other one. And if it's not, you've done the wrong thing. Okay, right, let's go on. Because what happens in the task, you do have a calculation like I gave you just now. I mean, not exactly the same, but that sort of thing. And you also have to work out from a given set of titer values. So what I've done here, I haven't told you exactly how much of substance A I've got. I've just given you the titer value. So if you were doing the titration, right, Carol, good question. When you do a titration, then you've got your burette, which is your long tube with a tap on the end, okay, and you add in the titration, you add a certain volume of substance. Now this volume of substance you add is called a titer, as in well, there it is. Okay, T-I-T-R-E. It's just simply the amount you've added from the burette. And when you do the practical titration, you have to have at least 3 values that are what we call concordant. In other words, they have to be close enough together. So I've given you different titer values. So this person has done 1, 2, 3, 4, 5 titrations. Okay, 17.6, 17.2, 16.9, 17.1, 17.3. Now, at an excellence level, for level 3, we consider values within 0.2 to be concordant. In other words, they are precise enough, they are similar enough. So if I compare 17.6 with 17.2, are they within 0.2 milliliters from each other? No. Okay, so I've got to drop one of them. I don't know yet which one I've got to drop. How about 16.9? Is that within 0.2 of any of those? No, okay, because it's actually within 0.3 of this one, and it's within 0.7 of that one, so, the first one. So that doesn't help. What about 17.1? Is there anything that's within 0.2 of that? Yes, there is. Now, it is within 0.2 of this one, and it is within 0.2 of this one, and it is within 0.2 of that one. So you can go, yay, I've got 4 results all within 0.2. But are they actually all within 0.2? They're all within 0.2 of this one, I agree. Right, they are correct. They are not within 0.2 of each other. So I've got to look at each one. Is 17.3 within 0.2 of 16.9? No. So if I'm just going to change my color because it's rather messy, okay? My 17.3 is within 0.2 of 17.1, and it is within 0.2 of 17.2. But these are not what we say concordant, because they are not within 0.2. So when you do your titration, you have to find which three are within 0.2. And if you've got none within 0.2, you keep on titrating until you get three titer values within 0.2. There is an extra thing in the titration. It also has to be within 0.2 of the teacher's results. But I know Declan's already done the titration because I was with him when he did it. And you can say it's not too bad. You can get there to get it within the 0.2. So just see what the teacher's color, because the teacher should demonstrate how to do it and so on. So just have a look at what color the teacher goes to. And as I say, we try to be very helpful. We want to make sure you know how to titrate. So don't let that worry you. Okay, so we've now chosen our titer values, and we're going to assume that they were all accurate and so on. So now we're going to have to do our calculation like what we did before. So I can't remember if I put my, yes I did, okay. So my substance A is HCl because I know most about that. I know the volume, and I know the concentration. So my concentration of HCl is going to be 0.267, and I'm going to actually not write the units down, and I should, it's just because I want to hurry up a bit. My volume is going to be, now please show how you did this, just in case you made a careless error, okay, because minor errors you can still get, say, like merit and so on. So it's 17.2. So show which three titer values you accepted or you used. So 17.1 plus 17.3. Okay, and I divide it by 3. And what will your answer be? You can do it in your calculator, or otherwise you should be able to do it in your head, because it's the one in the middle. 17.2. Yeah. Okay. Now remember that's milliliters. Okay. So I need to convert to liters. So it's going to be 17.2 times 10 to the minus 3. Okay. Right. So now I do the sorry, I've gone blank. I have to work out the amount of substance. So N is equal to C times V. So I just multiply those figures together. And because I do want to finish this and I'm running out of time, I'm just going to do the straightforward calculation. So it's going to be 17.2 times 10 to the minus 3 times 0.267. And did you get 4.59 something or the other times 10 to the minus 3? Right, so we've got the units, we've got the amount, okay. So now we need to have the mole ratio. So just changing to a different color, and it's a bit, actually I might just tidy up here. Okay, right, so 1 sodium hydroxide is the same, is equivalent to 2 HCl. Now remember, this is HCl, So I've got twice the amount of HCl. So am I going to have a smaller amount of N for sodium carbonate or a bigger amount? Smaller, because I only have actually half the amount of HCl. So it's going to be a half. I now divide by the 2 and not multiply. Okay, so it's half times that 4.59. And I'm just going to go dot, 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 okay. And I'm going to just divide it by 2. And do you get 2.296 times 10 to the times 10 to the minus 3. Okay, and have a look. Is this number smaller than that? So that's just a check, always sort of check each stage, and that's mole. And now of course we just do the final step where we go up to work out the concentration by using the volume. Oh dear, I think we'll have to stop here. We've got our fire alarm going, as you can see. Are you okay to work out the rest? Because I won't be able to be back. This is the end of the lesson. Sorry, I haven't been able to do empirical formula, but okay, so I'll just say bye.